All right, let's talk about the #1 performance killer in Delphi mobile apps, the dreaded, infamous UI freeze. You know exactly what I'm talking about, right? If you've ever built a FireMonkey app for Android, you've felt that pain. Everything runs beautifully on your super fast desktop, but the second you deploy it to a real device, it stutters, it lags, and sometimes it just gives up. Today, we are going to get to the bottom of why this happens and, more importantly, figure out the architectural mindset you need to go from a frozen, frustrating app to a truly fluid user experience. You know, sometimes the best advice is the most blunt. This quote from a developer on Reddit just cuts right through all the noise and gets straight to the point. It perfectly frames our entire discussion today. The community gets it, the experts preach it, and by the end of this, you are going to understand it on a gut level. Almost every single responsiveness problem you'll ever face comes down to how we treat one very special, very overworked thread. So let's paint a picture of this nightmare scenario. You've poured your heart into building a great app with amazing features, but when a user tries it, it just feels cheap. They tap a button, and for a few agonizing seconds, nothing happens. They try to scroll a list, and it stutters and jumps all over the place. Now, this isn't just a small bug. It's the absolute kiss of death for user retention. It screams low quality, and it all leads to one dreaded outcome. 5 seconds. That's it. That's the ticking clock on Android. This is the absolute maximum amount of time your app's main UI thread can be busy before the operating system itself steps in and declares your app broken. If your app doesn't respond to a user's touch within that 5-second window, Android throws up its hands and shows the user that infamous application not responding dialog box. You know the one. It gives them a great big button to just kill your app, and trust me, they will press it every single time. And here's a real-world example of just how bad this can get. This comes from an actual case study. A task that took just 3 seconds on a PC, a minor delay, maybe you grab a sip of coffee, that exact same task on a mobile device ballooned to a staggering 17 seconds. For that entire time, the UI was a block of ice, completely frozen. This is the perfect illustration of how something that's just a little slow on your desktop becomes an app-killing eternity in the mobile world. So this brings us to the absolute core principle, the one commandment of mobile development that you simply cannot, under any circumstances, break. See, the problem isn't FireMonkey and it isn't Delphi. It's a fundamental rule of how mobile operating systems work. If you want to build a responsive app, your #1 job is to become a fierce, uncompromising bodyguard for one thing, the main thread. So what exactly is this main thread? Well, think of it like a single-lane highway for everything the user sees and touches in your app. It is the one and only thread allowed to paint the screen. It draws the buttons, it processes the taps, it runs all the smooth animations. Its job is to constantly work through a queue of small, fast tasks to keep the UI feeling alive. But if you give it a big, heavy, long-running job to do, that entire highway slams to a dead stop, a total traffic jam. Nothing gets drawn, no touches get processed, and your app freezes solid. So, who are the usual suspects? What are these heavy jobs? Well, here are the most common culprits. Right at the top of the list with a risk level of extreme are REST and network calls. Why? Because you have zero control over the network. A call that takes half a second on your office Wi-Fi could take 10, 20, even 30 seconds on a spotty cellular connection. Right behind that are database queries and loading images. Both are surprisingly slow. Even parsing a big chunk of JSON can be just enough to push you over that 5-second limit and trigger that ANR dialog. Okay, so if the main thread can't do any of this heavy lifting, who's going to do it? The answer is simple: delegation. The entire strategy for building a fluid app is to offload every single one of those risky operations to a background thread. And in modern Delphi, the standard, smartest, and most efficient way to do that is with the Parallel Programming Library, or PPL for short. The PPL is amazing because it gives you this high-level, easy-to-use way to manage threads. So instead of getting bogged down in the messy, error-prone business of creating and destroying threads manually, which is a slow process in itself, you just think in terms of tasks. You basically wrap up a piece of work you want done, hand it off to the PPL, and say, hey, go run this in the background for me. It is so much cleaner, safer, and way more performant. Let's walk through how this works. Step 1, the main thread gets a request. Let's say the user taps the download button. Now, instead of starting the download itself, it moves to step 2. It uses task.run to delegate that job. The PPL immediately grabs a ready-to-go worker thread from a pool and tells it to get to work. And that brings us to the most beautiful part, step 3, freedom. The main thread is instantly free. It doesn't wait. It immediately returns control to the user, keeping the app perfectly responsive, ready for the next tap or scroll.
And right here, this is the most critical question in this entire process. So our background task is finished, it's downloaded the file, it's fetched the data from the database. Now it needs to tell the UI what happened. It needs to update a progress bar or fill a list with the new data. But remember our golden rule. Only the main thread is allowed to touch the UI components. If you try to change a label's text from a background thread, you're going to cause all sorts of chaos, instability, and crashes. So how do we get that information back safely?
This brings us to the absolute heart of this entire explainer. We have a choice, a duel, really, between two methods on the TThread class, synchronize versus queue. Now, at first glance, they look almost identical. They seem to do the same thing. But I'm telling you, the difference in how they behave is the difference between an app that flies and an app that crawls. This isn't just a simple technical choice, it's a deep, philosophical one that will define your app's entire architecture. So at a high level, the difference is simple, but it is so profound. TThread.Synchronize is a blocking call. It's synchronous. It makes a request and then it stops and waits. TThread.Queue, on the other hand, is non-blocking. It's asynchronous. It makes a request and then immediately moves on with its life. One forces a direct, waiting connection, while the other just sends a message and decouples the work. Let's really dig into what that means with a couple of analogies. I want you to think of synchronize as making a mandatory blocking phone call, okay? So, your background thread is busy. It's chugging away, processing data. Then, all of a sudden, it needs to update a progress bar on the screen. To do that, it calls synchronize. At that exact moment, your worker thread stops everything it's doing. It is frozen, on the phone, waiting on that single line of code. It will not do anything else until the main thread is finally free, picks up the call, does the UI update, and then hangs up. Now look at this code. It seems so innocent, right? I mean, a lot of us learned to do it this way. The worker thread is calling synchronize to safely update that progress bar. But the hidden cost here is absolutely immense. Your background worker is now completely changed to the UI thread schedule. If the UI thread is busy running a little animation, your background processing grinds to a complete halt, just waiting. You've effectively destroyed the whole benefit of multi-threading in the first place. Okay, now let's look at the alternative, TThread.Queue. This is completely different. Think of queue as sending a quick text message or firing off an email. Your worker thread needs to update the UI, so it calls queue. This is like it dropping a note into the main thread's inbox. And then, and this is the most important part, it immediately goes back to its real work. It does not wait for a reply. It is a true fire and forget operation. It trusts that the main thread will get to that message and process it whenever it has a free moment. And here is the much, much better approach. The code looks almost identical. We literally just changed one word from synchronize to queue, but the architectural impact is massive. The background thread is now completely decoupled from the UI thread. It can process its data at full speed, just queuing up UI updates whenever it needs to. This allows for true, genuine parallelism. Your background tasks can run at their maximum potential, leading to a dramatically more responsive and performant app. So here's the big takeaway. Choosing between synchronize and queue isn't just about picking one function over another. It's about fundamentally changing how you think. It's about adopting a modern, asynchronous architectural mindset. It's about designing your application from the very beginning with the understanding that the user interface's fluency isn't just a nice-to-have feature, it is the most important feature you can build. And that leads us to a new set of rules for building modern, responsive apps. First, use TThread.Queue by default. Period. This should be your go-to for all UI updates from a background thread. Second, only use synchronize in the absolute rarest of cases, like when your background thread literally cannot continue its work until it gets a value back from the UI right that second. Third, and this is the most dangerous trap of all, never, ever make the main thread wait for a background task that might internally use synchronize. That's how you get a deadlock, a deadly embrace where the main thread is waiting for the task and the task is waiting for the main thread and your app freezes forever. And finally, delegate all network, all database, all file operations off the main thread. No excuses, no exceptions. And that leaves us with one final big question to think about. It's easy to write code that just works, that performs a function, but it takes real discipline and a different way of thinking to design an architecture that feels fluid and responsive to the user. This shift in thinking, from synchronize to queue, from blocking to asynchronous, from just building for function to designing for fluency, that is the absolute key to building professional, high-performance Delphi mobile apps that your users will actually love to use. The question isn't just what your app does, it's how it feels while it's doing it.